All right, welcome to our Unit 2 review video for our Unit 2 test. And before we dive into the actual problems on the study guide, I want to cover a couple of things that are on the top of your study guide, but if you're making this up from home, I want to mention it and draw your attention to it, make sure we're clear on that. So you will be permitted to use Desmos for this test, but it does come with a couple of provisions. You must be on a school laptop and connected to the DCPS network, okay? Both of those things must be true. You have to be on a school computer and on the school network. If I cannot see your screen on LAN School, you will not be permitted to use Desmos, okay? And that's so that not anybody watching this video, but hypothetical people out there that might, I don't know, try to use the internet to get a leg up on their test. We'll put it that way. Now, if you are panicking at this moment because there is an issue with your school laptop, like it doesn't work or it restarts all the time or it has Wi-Fi issues, please speak with me on the morning of test day, okay? Or afternoon of test day if you're period 8, okay? I do have a workaround in place that we can use so you don't need to panic and you don't have to worry about somebody else having an advantage you don't have, okay? So don't panic, just come and speak to me. But that workaround won't work for the entire class. So if you do have a functioning school laptop, make sure it's charged, make sure it's ready to go, okay? Also, there will be different versions of the test. Now, there were different versions of the test last time, but not as many versions. And because, unfortunately, I caught several people with answers to a version of the test and not theirs, there will be more different versions, and every single problem on the different versions is different. So all of that to say, do not copy off your neighbor. If you are copying stuff off your neighbor's test, I promise you, you will fail the test because you will be copying all the wrong answers. Like, I don't even have to bust you for copying because all of the answers will be wrong. Okay, it's not that hard to study. You're taking a great step by watching this video. Make sure you grab some paper, or better yet, grab your study guide that you've already worked through the problems on so that you can use this video to check your work, okay? And that's going to go a long ways towards helping you be prepared for the test. But I wanted to make sure that I covered those two things, especially if you're not in class when we're doing the review. All right, without further ado, here are the first two on your study guide. So first one here, given a quadratic function, be able to identify what form it is. So there are three forms of quadratic equations. They are vertex form, standard form, and factored form. And you need to be able to identify them. So if you're looking at it, you will be able to say that quadratic is in vertex form or that quadratic is in standard form. So I gave you two examples. Now, obviously, there are three different forms, so this example doesn't cover everything. Make sure that you go back to the lesson where we covered the different forms of the quadratics and you are able to pinpoint which type is which. So for the review purposes though, this one right here is in factored form. And this one here is in standard form. So standard form is your ax squared plus bx plus c. Factored form breaks the quadratic up into factors. So we've got a factor of -4, and then we have a factor of x plus 5, and then we have a factor of 2x plus 1, and that's why it's called factored form. Vertex form is the form that we use for doing transformations. It's the a times x minus h all squared plus k. Okay, now that's going to be just a list of functions and a blank to the side, and you are going to fill in that blank with either vertex, standard, or factored, depending on what form it is. Okay, now the part of the study guide, these are good, but if you realize I was absent the day we did that, I still don't know what vertex form is, you need to go into a little bit more studying than just watching the video. Go pull your notes, go pull the PowerPoint from that day, go pull the video from that day, and make sure that you have that. Or you know that we will review the day of the test, so bring that question with you to the review session. Second item on your study guide is be able to identify the increasing, decreasing, positive or negative interval or intervals on a graph, and then match the correct notation with the interval you chose. So there's actually a couple of these, but they look like this. So we have here a graph, and the directions for the study guide say highlight the negative interval or intervals on the graph. You will see a couple of these, and even though the study guide is just covering negative, make sure that you also know like where the increasing, where the decreasing, positive and negative intervals are. If you want me to review that in the time that we have before you take the test, mark this on your study guide and be ready to ask that question. This one is asking us just for the negative interval. Well, negative means below the x-axis. And so what I'm going to do is highlight below the x-axis. Okay. I'll turn my laser pointer on, if it had asked for positive, I would highlight the two intervals above the x-axis. If it had asked for increasing, I would have started at the vertex and I would have highlighted this section here that my pointer is on. If it had asked for decreasing, I would have been over here where it's going down and stopped at the vertex. Okay, so I did go over those. Now, the question that's going to be paired with this is going to say something like this. Which of the following matches the interval you highlighted? So let's just say hypothetically, you don't know what the negative interval is, but you pick something. Whatever you pick, make sure that your answer to this matches it. So this was the negative interval, and I believe that is going from x is 2 over to x is 5, and so for this one, it is answer choice C. But it's going to be a separate question. So even if you get the question before wrong, you can still get the question after it correct. So in a total pinch of, I have no idea what this is, find an interval, like on the multiple choice part, and then highlight that interval on the graph, and then at least you'll get the points for the second question. And you have a 1 in 4 chance that 1 in 4 chance, assuming that you know what the different the 4 things are. But I did see people highlight things on graphs that weren't any of the 4. So, but in theory, like a 1 out of 4 chance. Okay, so there will be a couple of those. I know last time we had the study guide, people were like, oh, there's more questions on the test than on the study guide. Yeah, that's because there's like more than one of these. So we practiced with a negative one, but you could see increasing, decreasing, positive, or negative on your test. If you need to do a little bit more review, like this is your tip off, like, ooh, I got to review the difference between increasing and positive because I know I get those confused. Okay, I messed that up for a hot second. I clicked onto the next slide. So I apologize for the smushed writing there. That is me trying to get the questions and the Desmos onto the screen at the same time. But hopefully you have a copy of the study guide in front of you, or you can pull one from the Teams page, or you can read it just fine. I think I'm going to be able to read it. Okay. So 3 on your study guide says, be able to state transformations of a quadratic from the parent function. So this is the most straightforward version of this question that you can get if you understand what the parent function is. And hopefully you can do that without using the calculator, but like I said at the beginning, you will have access to Desmos. So if you're not sure, you can go ahead and hop onto Desmos and graph it. But what we're looking for here is we're looking for this. We're looking for the fact that the negative will flip it over, and the fact that the +3 on the inside will make it go left 3, and the +1 on the outside will make it go up 1. So the way you would write your answer is something like this. And I am okay with you just saying flips, because at this point, we're really only flipping over the x-axis. If you want to say flip over the x-axis or reflect over the x-axis, that is a little bit more precise, but don't feel like you have to. I think we're okay assuming that for now. And so your answer would look something like that. And I just did that with the arrows to reinforce where we're getting that from. Now, let's just say you're not sure of that. You can come over here to Desmos, and you can go ahead and type in g of x equals negative x plus 3 all squared plus 1. And hopefully from that, you can see that it is flipped over. From the parent function, it is left 3. Again, you want to look at where that vertex is. You can see that vertex has gone left 3, and the vertex is up 1 from the parent function. Okay, so feel free to do that for a little bit of extra confidence. Now, I put the Desmos on here more for the fourth one, which is be able to state the transformations to get from one quadratic function to another. So this one is a little bit trickier because you're not starting at the parent function. You're going to start at some other function. So I'm going to go ahead and delete that one and type in function f, which is x plus 3 all squared minus 1. So that blue function there is our starting point. So we're going to start at function f, and then we're going to go to function g and make sure that you are practicing on Desmos. Desmos is a phenomenal tool, but one of the ways you can get hung up a little bit is if you're not practiced at using it. And that includes just how fast you can type on the keyboard and access the menus. And you will get faster the more you do it. So you want to get that practice in before you take the test. So to get from the blue graph to the green graph, what are we doing? I can see that we had a compression or not a compression, sorry, a stretch. So I can see that we are stretching the graph out because the blue one is skinnier, or the green, oh, good grief, I'm not doing well today. The green one is skinnier than the blue one. Okay, I can also see, and we're going to look at the vertex. Okay, the vertex of the blue one is here, the vertex of the green one is here, and to get from one to the other, I go right 1, 2. Okay, so I went right 2, and then it looks like I am also going down 2. Okay, now notice how I did that. If you need to rewind that, and I apologize for tripping over my words, because go me. But what I did, I'm looking at that vertex, and to get from the original vertex to the new vertex, we are going right, and then we are going down. And then you would count how far. You can also get that, and here I'll use my pointer, so to get from the blue vertex to the green vertex, right 2, down 1, and then the green, it has also been stretched out, which you can tell from the 2. Okay, so the 2 stretches it out, and then we were left 3, and now we're just left 1. Which means that we slid right 2. We were down 1, and now we're down 3, which means we slid down 2 more. But I think for a lot of you, it's easier to see on the graph. You will be graded only on what you write for the response. Okay, so how you get there is not how you're going to be graded. All right. Okay, there we go. Oh, that's right. I had to re-record on this slide. Hang on. I hate it when I kick myself out while I'm recording because it's just such a mess to hop in and hop out. But and I'm probably, this sounds just weird because to you guys it's just a video. But anyway, trust me, there's a lot of drama going on. All right, number 5. Be able to write a quadratic function given the transformations. Now, this went very, very well in class and on your homework, okay? So this, if you're really nervous about the test, if you didn't do so well on the first one and you're trying to come up with a game plan, one of the things you want to do is find out, like, what am I most confident in? This might be one of them. So the example here is write a quadratic function that is flipped over the x-axis and goes left 3 and up 2. It's essentially the reverse direction of here is a function, tell me the transformations. And so you might write something like this. To flip it over the x-axis, you would make it negative out front. To make it go left 3, that would be plus 3 on the inside, and up 2 is plus 2 on the outside. Before we leave this though, if you did your homework, okay, and you turned it in on time, then what happens is I try to give you a little bit of feedback when I hand that back. I mean, it's tough because I'm going over a lot of homework and I got to do it in a short amount of time. But here were the main things that I noted on the homework. On the homework, it wasn't a deduction unless it was mathematically incorrect, in which case you might have lost a half a point. But if you do this on the test, I have to take off more. So just to remind those of you that might have gotten some feedback on your homework, if it says to write a function or write an equation, there has to be a y equals. Okay, has to be a y equals. The other thing that was problematic was dropping the squaring off of the function. And so people would just write x plus 3. If it says to write a quadratic function and you write x plus 3, that's not quadratic, that's linear, because quadratic has to have that x squared in it. You have to make sure that you square it. So just note that there were a lot of people that did that on the homework assignment. They had the transformations done correctly, but left out the y equals or f of x equals, okay, whatever floats your boat, and they dropped the x's, the squareds off that. If you dropped the squareds off when I handed you your homework back, I handed it to you with the squares put in as like some feedback from me to you. So hopefully you looked at it. Question 6. Given the x-intercepts, be able to find the axis of symmetry and identify a possible location for the vertex. So there's going to be dual questions on this. You're going to find the x-intercept, and then you're going to have to identify a possible vertex. So the best way to do this is probably to sketch it out. Now, there are some formulaic ways that you can do that, but for most of you, this is how you want to do it. Okay, so on your test, you're going to 1, 2, 3, 4, 5, 6. You're going to do a quick coordinate plane. Negative 2, 0 is right there. 2, 3, 4, 5, 6. Negative 6, 0 is here. So those are the x-intercepts. What do we know about the axis of symmetry? We know it's right in the middle of the parabola. So you would find the middle. There it is. That is at x is equal to -1, -2, -3, -4. And so the equation for the axis of symmetry is equal to x is equal to -4. Make sure if you are asked for the axis of symmetry that you state it correctly. It is the equation for a vertical line through, in this case, -4. If you just write -4, I know that you knew what to look for, but you did not use the correct notation. And while sometimes on computer-based tests, that doesn't matter because you can just like check off the right answer. When you are the one doing the writing, it is important. It's not inconsequential. Okay, so now let's talk about the next part of that. Identify a possible location for the vertex. The vertex has to also be in the center of the parabola. It's on the axis of symmetry. So whatever I know about the vertex, I know that the x-coordinate has to be -4. So if you saw a bunch of different answer choices and they all had different x-coordinates, you would want to pick the x-coordinate that matches the x-coordinate for the axis of symmetry because the vertex is on the axis of symmetry. So it doesn't even matter what that other number is there. That would be a possible vertex, okay, for you to have. And on your test, there will only be one answer choice that is a possible vertex for you. So you don't have to worry like, well, what do I do if there's more than one point that has a -4 for the x-coordinate? Won't happen. They're all going to have different x-coordinates. You just have to pick the one that goes with your axis of symmetry. And again, there's different versions of the test. Your neighbor has a different axis of symmetry. Don't copy. All right, now I have to stop the video again because I'm having a day. But I should be okay now, unless I mess it up again. So, fingers crossed. All right, Number 7, given the vertex and a point on the parabola, be able to find another point on the parabola. So we have if the vertex of a parabola is at -2, -1, and it goes through 2, 3. Now, there's different ways that can be phrased. I wrote it here. It goes through, it being the parabola, goes through 2, 3. But you might also see it passes through 2, 3, or it contains the point 2, 3. So those are all different ways of saying the same thing. Like the parabola contains the point, or it goes through the point, or it passes through the point. So best way to do this, like the previous one, is to take a look at it. But I don't recommend Desmos for this. What I do recommend, though, is making sure that you are paying attention to negatives. Okay, on Unit 1 test, there were all kinds of points that were plotted incorrectly because people were just not paying attention to negatives. So -2, -1, like put it in the right spot. Now, this point, this parabola goes through the point 2, 3, which is going to be over here. Okay, now here's what we know. We know that parabolas are symmetrical. So if you put in your axis of symmetry, you know that there must be another point over here that mirrors the point that we were given, the point 2, 3. So the mirror point is going to be the same height. So it's going to be 3 up. So we got that much. Okay, but it's going to be on the other side of the axis of symmetry. So I'm going to go ahead and put some more tick marks up there, and let's just count it out. So I go 1, 2, 3, 4. Make sure that you do count the y-axis, okay? So I'm just counting across. 1, 2, 3, 4. And so I've got to go 4 more over here. 1, 2, 3, 4. It is going to be like right about there. And let's make sure that we're counting. So this is -2, -3, -4, -5, -6. Okay, now what you can do is you could go into Desmos and then plot all 3 of the points and make sure that you counted correctly. But really the way this one ends up being wrong is if you just don't count correctly. So take your time, do a nice graph for it, and count and double count and make sure. If you like if you averaged, no, you know what, I don't want to go there. I was like, I just don't want to go there. Just count correctly. Okay, so slow yourself down. All right, next one, be able to determine the transformations on a parabola from a table. So we did a couple of these in class. So we have function f, and as we said, if I'm only going to give you certain ones, like I'm not going to give you ones that we didn't do in class. So whatever you see on your version of the test is something we did in class. If you look at the f of x goes through -4, 10. G of x goes through -4, 12. Okay, so it's like a little, it's going to have the same x coordinate, but it's a little bit higher up. In fact, it's two further up. Then go across the table, see if you can find the pattern. So 15 to 17, that was 2 up. 20 to 22, 2 up. 15 to 17, and then 10 to 12 again. And so what we can see here is that g of x is equal to f of x, but it's +2. Now, the question is asked for the transformation. So once you determine what the transformation is, you do need to say it. In this case, it is up 2. If you just leave it as g of x equals f of x +2, I would be inclined to give you most of the credit, but I still want you to know what that does. That makes it go up 2. Okay. The ones that we did in class, we did up, down, and flip. We did not do the horizontal ones in class, so don't pick horizontal don't write that down like left, because we didn't do any of those in class. So up, down, and flip. Those are the ones you want to make sure you know. If you need to review that more, go back into the videos, find the video where we did some of that. I think that was Unit 2, Lesson 1, where we looked at a couple of tables. So you can kind of fast forward to that and you can go over like, oh, what does it look like if they are flipped? All right. This one, we are almost done with this review video, which is awesome. So this one says, be able to state the vertex, axis of symmetry, min, max, and domain and range for a parabola. You are expected to use Desmos on this. If you don't use Desmos, some of you might be able to do this because you demonstrated that you did know the vertex formula, and you did that on your classwork. So you did the opposite b over 2a and then plugged it in and you found the vertex. And then once you have the vertex, the rest of it is pretty good to go. This one has a negative x squared, so you know it will be flipped over. And so you could do a sketch from there. You are welcome to do that. I think you can probably do it in the time that you have, but you do not have to. So the intended way for you to do that one is to take a look at it. So we have f of x is equal to negative x squared minus 6x minus 4. And you would then look at the vertex. On your test, there will be a table for you to fill out so you don't have to keep track of everything. But here we go. Vertex, negative 3, 5. Axis of symmetry goes right down the middle and will be at x equals negative 3. In this case, we have a maximum. The maximum is at y equals 5. The domain of every parabola on planet Earth is all real numbers. I just before recording this, I went through all the classwork from Friday's class, and there were some weird notations. That is not an IR. It's not two separate things. It's just an R for all real numbers. Like the R stands for the word real. Just because of what it is, it's like an R, okay? And all there is there's like a little double bar on the back of the R, but it's just an R. Now, it's hard to type that. So sometimes when you see this type written, people will just maybe bold it. You know, they'll just put the R, like a regular capital R, and they'll bold it. But there were a lot of notations on the classwork that looked something like that, which is not what it is. And so, yeah, before we leave that, I wanted to maybe address that. I did not take off if you did that on your classwork, but I do want to point out that it's not an IR. And your range, last but not least, the range is always y coordinates, and it has something to do with that 5, and then you have about a 50-50 shot of greater than or less than. This one, the parabola is going down and it's maxing out at the 5. So all of your y values have to be less than 5, or they could be equal to 5 if they are at the vertex. So there are a couple of those on your test. You are welcome to use the formula, but what I would do is just watch the clock, because if you insist on using the formula and then you run out of time, that's more bad time management instead of doing the problem the way you're intended to do it. So I would do the graph on that on Desmos. There we go. Okay, and then the last one is be able to interpret the key characteristics of a quadratic in the context of a word problem. So you'll notice that this problem hopefully looks familiar, and I did not put Desmos on the screen because I said to myself, I already recorded a video where I did this same problem. I shouldn't have to record it again. So hopefully you were in class the day we did this, and so you have it written out and you remember how we did it. If not, or if you were in class but you just don't remember, go and look at the video for at least, I'm like recording this way in advance, but it should be September 28th. okay, where I will go through this problem. But basically, you will see a problem like this on your test, and you will be expected to dump it into Desmos and then answer the questions. So what is the frog's maximum height? You would be looking at the y coordinate of the vertex, okay? But you'd have to give me the number, okay? Give me the actual number. How far from the stump did the frog land? That would be the x-intercept, and it's going to be the positive x-intercept, not the one that goes backwards in time. And then what was the frog's horizontal distance from the log at her maximum height? That is the x-coordinate of the vertex. And again, if you on your test start writing down the points and not the numbers, then I'm going to suspect that you put the video on mute and you weren't actually listening to me tell you that you had to put the numbers and you thought this was the answer because you weren't listening. Unmute it. All right, so that takes us through the entire study guide. Hopefully you'll get a chance to watch this before the review day, or you'll do it if hopefully you get a chance to watch it. And it can drive some of your question asking on the day of the test. You guys know where to find me. As always, let me know if you have questions.